ठीक है। ओके, सबको स्क्रीन नज़र आ रहा है? अच्छा, सही है। ओके। uh, the problem in this case is कि अच्छा, you have an array of numbers, and the idea is that you're going to start at the 0th index and you want to get to the last index. And the jump can, you simply have to return true or false. You will return true if you can get from this index to the fourth index. Now, how do you move from this place to this place? Well, whatever place you're standing on currently tells you the maximum number of indexes you can jump forward. So if I stand at 2, I can jump yahan tak ya yahan tak. The maximum. This defines the place I'm on, tells me how high I can actually jump from here. So this guy can move on to the first or the second index. That makes sense? This guy can move 3 places forward at max. This guy can get 1 place forward. This guy can only go 1 place forward, and this guy can go 4 places forward. Obviously, it doesn't really matter. Um, the question here is, can you actually get to the last index? Okay. Now, does anyone have any approaches as to how you would approach this question? Like, so what would be the first observation you could make in this question? What would be like the cases that you would have to consider? You guys are all free to open your mics. हाथ खड़ा करके बोल लो, type कर लो. मेरी आवाज़ आ रही because I haven't seen anyone reply to anything yet. Guys, you can hear me, right? Are the area values positive? Aga, yes, they are all positive. So I say yeah. Aga, you can only move in the right direction. They're all positive. ठीक है. Does anyone want to make any guesses as to how you'd go about this question? There's no wrong answers. Just I want to see how you guys approach these questions. As you know, this is a DP question, so if you work along DP, so that would be better. Like, and you can suggest any non-DP algorithm that comes to mind for this as well. Can we say that if all indexes are greater than 1, then we can just do a single jump for all? That's true, Zoha. That's a very good observation. If all of them are positive, then the answer is arbitrarily true. बिल्कुल सही कहा. So there have to be 0 indexes in the actual. There should would be a बिल्कुल सही आगा साले. If you have 0 indexes, those actually are places that you can actually get stuck on and disallow you from proceeding further. तो अच्छा, let's say हमारे पास 0 आ गई values. Positive है तो बहुत आसान है. Let's say 0 values आ गई. Now how are you going to find out? What's the naive, what's the brute force way to do this? So, in case anyone hasn't picked this up, the brute force way to do this would be actually just start at the first index, explore all possible paths. So this guy says you can go over here or here. So you can put these 2 indexes like in a queue or something, right? And then you'd go to those indexes. So this guy allows you to go to 0 plus 1 and 0 plus 2, right? So 0th index, 0 plus 1, 0 plus 2, right? So you make like a queue or something and you push in the queue 1th index and the 2nd index. These are locations that you're allowed to go, and then you'd go to those locations in the queue. You'd pop from the queue and you go to those locations, and you'd stand at that location and ask this guy, अच्छा तुम कहाँ जा सकते हो? और ये कहता अच्छा है तुम यहाँ पे जा सकते हो, यहाँ से जा सकते हो, यहाँ से जा सकते हो. ठीक है? But the thing is, this would add repetitions into this. And the whole idea of DP is that you want to be removing locations that you've already seen, right? So this guy would say you can go here or here, but then you'd visit this guy and he'd also say you can go here. So this guy would be coming, multiple times in the queue, right? So you would actually like to avoid this problem. So yeah. So let's think backwards. If, let's say, the answer to this array was true, if the answer to this was true, then standing at the last index, if I stood at the last, if I can actually finish this game, that means I can stand at the last index, right? Given that I can stand at the last index, that means that some guy got me to this index. So just look behind me. Look at all the people who actually got to my index, who can actually get onto me. So so this guy can jump onto the last guy. This guy can also jump onto this guy in one jump. Basically, I'm saying in one jump, can this guy, which indices before me, can actually reach me in a single jump? Well, that's this guy, and then this guy. ये वाला बंदा और ये वाला बंदा नहीं कर सकता, right? So then you'd go backwards and ask these guys, are you reachable? Because if you guys are reachable, then I'm reachable. That makes sense? So you'd ask this guy and you'd ask this guy. And the process would be the same. You'd ask everyone behind the 3, can this be reached by any person behind me? And the only person behind me is 2. And so the answer is yes. And so you'd immediately know the answer is there's at least one path. So you'd know कि अच्छा हाँ 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 हम कर सकते हैं. In this case, you'd ask to have this guy, can you reach this guy? And you'd ask everyone behind this guy, is this guy reachable? This guy would say yes, this guy would say yes, this guy would also no, this guy would say no. Ye directly cannot reach this guy, right? But this guy would say yes on this guy and this guy. Then you'd ask either of these guys, are you reachable? Right? But programmatically, think of how that would work. You would start at the n minus 1th index, and you would look at all previous indexes in the range 0 till n minus 1 not inclusive, like so n minus 2 basically inclusive tak. And you'd ask all the indexes from 0 till n minus 1. You guys know this notation, right? This means not included. So you'd ask all indices before me, can you reach me? So I plus the value of I plus nums of I is greater than or equal to. Can I actually jump up till or more than the last index? You'd ask everyone behind me, and that would actually be an O of n operation, right? So you don't actually want to do that. You can actually do this, but the smarter way to do this would be start from the left. ठीक है ना? Make an array, उसके अंदर भर लो. Initialize the array like this: false, 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 false. This basically means that currently I think all of the forward values are unreachable. And then we'll start filling this array up. And the goal is, so false here dictates that this guy abhi tak, so far I think he's unreachable. So the first thing that you can do is actually you can remove and make this guy a true value, because this guy is always reachable because you started this guy, right? So you'd start at this guy and you'd start actually building up towards your answer. If you'd build up towards your answer, what would you do? You'd stand at this guy, you'd make all the possible values from this guy true. है ना? So you'd go आगे and you'd ask him, अच्छा और कौन सी values true है? So which values would this guy make true? He would make this value and this value true, right? So this value and this value would become true. ठीक है? And then you'd move forward to the next value and you'd make all the values in this range true. So this guy, and that guy. Okay? So this, and this would become true. And that's the dynamic, basically, that's a DP approach to be solving this. However, this is a fairly easy problem because if you think about it, all the operations are for if you made a for loop for this, for I in nums, you would just be saying basically the for I in range, length of nums, you'd visit the ith index, and for all the indexes I plus nums of I tak, you would make them true, है ना? And then you'd visit the next index और उसके आगे सबको true कर लो, फिर उसके आगे सबको true कर लो, फिर उसके आगे सब true कर लो, ठीक है ना? And that would actually save you the hassle of looking at everyone behind you, right? Because अगर आप forward से कर रहे थे, you'd have to be looking at everyone behind me. You'd have to check every possible index behind me who could actually jump onto me. In this case, you only jump onto जितने भी आगे indexes that are actually now becoming legal because of me. So this guy makes these two legal, right? This guy makes these three legal, right? That's how you'd be doing. And the moment you went and made an index that was n minus 1, if you made n minus 1 wala index true, then you would break the loop and you would return true immediately. So yeah, that's the easy approach. So this is the easy form of jump game. Let's look at a slightly harder version of jump game. ठीक है ना? The harder version of jump game is, what is the minimum number of jumps that I can get to this index? How would you approach this problem? Now, you guys have already seen how you approach the simpler problem. You can use some information from the similar problem because it's a very similar problem. You can obviously see that. How can you actually use the answer from the simpler problem to help us in building our answer towards a slightly harder problem, which is, what are the minimum amount of jumps I can use to get to the last value? किसी का कोई approach है?
array size के जितना अगर number हो कोई
So you're saying the answer would be the array size?
yeah, if we have a number that is the size of an array, the size of the array, so maybe use that.
Well, that would be one answer. But currently, we're asking for any given array. In this, let's say in this case, this is the array. We're saying that for any given array, you're standing at the first value. You would like to get the last value. How can I find out what's the minimum amount of jumps I can do? Basically, the best path of jumps I make to get to the last index. Now look, I can do this. 2 से इस पे आया, इससे I choose to make one jump, इससे I choose to make one jump, but that's a very bad route, right? What you could have done is यहाँ से यहाँ तक और फिर यहाँ से वहाँ तक. And that would have been 2 jumps as opposed to uh, 1, 2, 3, 4 jumps, right? So how would you actually find out? Sorry, could you clarify the approach for the simple problem? How is that? How is that not brute force? Salik, if I was doing brute force, I would be exploring every possible path, right? So I would. So it's actually very similar. What you're doing is actually very similar. But in the brute force approach, you would actually say it's very. You're right. It's very close to the brute force approach. But the brute force would actually look something like this. This guy can go to this, and then this. So look at the brute force approach. How many paths can you make? You stand at this guy, and then this guy gives you two choices to land on. ठीक है ना? The first choice is this, the second choice is this. The first choice would give you three possibilities, the other choice would give you one possibility, right? If you stood at this guy, the first choice would give you three possibilities, the other would give you one possibility. Of those three possibilities, each of them would give you one, and one possibilities. In this case, this guy would give you one possibility, and then you'd have to start this all over again for the second guy. This is just the route of कि अच्छा मैं अगर दो से शुरू किया, ठीक है ना? So you're right. This is fairly. It seems similar to the brute force one, but it's like it's the least amount of work you're doing to find actually the answer. The brute force one actually uses a lot more computation. I hope you got that. Let's go back to the original question, which is how would you find the minimum amount of jumps? Also, Salik, you'll see how this definitely, like, the answer might have been very close in the true or false equation, but in the minimum jumps wala, then the brute force once becomes much more apparent because then you'd have to be observing all the possible routes. Can someone recap what we are doing just in the Sahil? What we're doing is we're doing something called a jump game. This is a DP problem. The idea of the jump game is you have an array of integers, positive integers. You are standing at the 0th integer and you would like to get to the last. You are starting at the 0th index and you'd like to get to the last index. Now the way you jump in this game is basically the index that you're standing on allows you to make at max this many jumps, so the value of the index that you're on. So if I'm on a 2, then I can make either +1 or +2 jump, ठीक है ना? And then I can go over here or over here. फिर जहाँ भी मैं खड़ा हूँगा वहाँ से I can make that many jumps. So I'm allowed to make as much as यहाँ तक जा सकता हूँ, 1, 2 और 3, +1 या +2 या +3 कर सकता हूँ मैं. फिर जहाँ भी खड़ा हूँगा फिर वहाँ से मजीद मैं वहाँ जा सकता हूँ. So wherever you're standing on, that allows you to go a little more further distance, right? You don't have to use all of the 3. You can use a bit of the 3, but you can only go as much as the current value that you're on at max. And so the question right now is basically we observe that acha, if you wanted to find out can I get from the 0 to the last index, that's a fairly simple problem. We're not to find out okay, what is the minimum amount of jumps that I can make to get from the 0th index to the last index. Okay. Now let's actually think of this recursively. Okay, na? Let's say I ask you. So for currently the question is asking me min jumps. Currently, the question is asking me min jumps of n minus 1. So basically, how many jumps do I need to make to get to the n minus 1th index? Okay? Let's say you know the answer of min jumps, all of these. n minus 1 का आंसर नहीं पता, लेकिन you know all of these answers. Okay? In that case, how could you describe the answer of min jumps this guy in terms of the answer of all of these guys? You know the min jumps to get to here, you know the min jumps to get to here, you know the min jumps to get to here, and you know the min jumps to get to here. I would like to know the answer of min jumps to get to here. How would I find that? I would like to get to the last index. I know the number of minimum jumps I need to make to get to any index before me. मुझे इसके जवाबात पते हैं कि what is the minimum amount of jumps I need to get to any of these indexes. कि अगर अच्छा मुझे यहाँ तक पहुँचना था या मुझे यहाँ तक पहुँचना था या मुझे यहाँ तक पहुँचना था, उसका आंसर मुझे पता है what is the minimum number of jumps I need. ठीक है? Let's actually make this a slightly larger array so you guys can actually see where this is a harder problem. I'm just going to put dashes here so you guys don't actually see the values, but you guys try to picture, getcha. I would like to get over here. And you know all of these answers. मिन जंप ऑफ आई, यहाँ के लिए इनको तुम्हें सारे आंसर्स पता हैं, ठीक है। अब मुझे बताओ, हाउ कैन आई फाइंड इसका आंसर? आई नीड टू नो व्हाट इज द मिनिमम ऑफ जंप्स आई नीड टू गेट टू यू। हाउ वुड आई फाइंड दैट गिवन आई न्यू ऑल ऑफ दीज आंसर्स? अब देखो यहाँ पर कोई भी वैल्यू लगी हो, 1 2 3 4 5 6 कुछ भी हो सकता होगा, लेकिन एंड वी आल्सो नो व्हाट इज द मिनिमम जंप्स आई नीड टू गेट टू यू। How could I find out one more than that for the known set? Sheikh Mohammed Shajil, you're on the right track. Could you explain it a little better? I think you're thinking the right thing, but explain it like thoda matlab, say it in a more like robust way. You're right about the one more Pala part, but one more from which index? किन index से मैं plus one करूँगा तो आंसर आएगा?
The second last index.
Why would you say the second last index? This guy, or you're talking
Yeah.
about today?
The one before X.
You're saying that you're gonna ask this index minimum jumps and you're gonna say plus one.
Yes.
Okay, so you're close. So Shajil, think about your answer. You're saying that I'm gonna ask the index immediately before me, what is the minimum number of jumps I need to get to you? And I'm just gonna do plus one of that. Okay? Shajil, in your answer, did you ever look at the value of this guy? No, right? So think about it. This value could have been a 0. And you'd know, अच्छा, let's say यहाँ पर 0 लिखा हुआ था, तुम्हारा इसका आंसर आ गया मिन जंप्स का, let's say 9 आ गया, तो यहाँ तक पहुंचने के लिए मुझे कम से कम 9 जंप चाहिए। तुम कह रहे हो कि इस तक पहुंचने के लिए मुझे 9 + 1 जंप चाहिए होंगी, which is not really necessarily true. It might be true if this was actually a positive value, but in this case it's actually a 0, which means I can't just assume कि पिछले वाले इंडेक्स से मैं आगे आ सकता हूँ। I need to be sure कि वो उस इंडेक्स से मैं आखिरी इंडेक्स तक पहुंच सकता हूँ। And if you actually think about it, you can actually extend your answer to actually more indexes, right? You don't need to actually ask the immediately index before me. You can ask this guy or this guy or this guy. But what condition needs to hold? You need to ask anyone before me. Well, can you ask each of the people before me, क्या आप पर अगर मैं खड़ा होता, मैं यहाँ पर वहां से आगे तक पहुंच सकता? Can I ask, if I was standing at this location, can I get to the last location? And that calculation is fairly simple. You just ask it, ith index plus nums of I is greater than equal to n minus 1. You just have to say, acha, if I stood at this index, let's say this index was 7 and you wanted to get to 3, if this value is 3 or more, which is an O of 1 operation, you just ask immediately कि अच्छा क्या तुम आखिर तक पहुंच सकते हो ये जंप के अंदर? अगर वो हाँ कहेगा, then I just take his value, I do plus 1 and I update this value, right? Because if let's say this guy says, acha, standing at me, I can actually get you to the last index, but the minimum jumps I need to get to me is actually, let's say 6. 6 is my stored answer यहाँ पे. So then the last answer would actually be 7. Catcha, the minimum number I need to get to you is 7, given that you actually jumped from here. But I don't need to jump from you, right? I can jump from any of the people behind me. So I have to do the exact same thing I was doing before. याद है हमने पहले क्या कहा था? हमने कहा था कि if I want to find out whether or not I can actually land here, I'd have to ask everyone before me who can jump onto me in one jump, can I get to you? So I would ask everyone before me, क्या आपसे मैं एंड तक पहुंच सकता हूं? अगर हाँ, तो फिर क्या आप तक पहुंच सकता हूं ट्रू, तो फिर मैं भी ट्रू हूं, ठीक है। अगर आपसे पहले सबसे पूछूंगा क्या आप ट्रू हैं, बेसिकली which means can I get to you? If you say yes, then I'd ask you, can you actually get me to the last index in one jump? And if that answer is yes, then I'd say, acha, you are also a yes, you can also get to you. In this case, it's the same concept, but you'd be asking the guy behind me, acha, let's say I ask this guy, I'd have to ask everyone behind me, obviously. Let's ask this guy, this guy, this guy, this guy. Let's say I'm asking this guy right now. I'd ask this guy, well, can you actually help me get to the end in one jump? And if that guy's value allows you to get to n minus 1 or greater, then you'd say, acha, what is the minimum number of jumps I need to get to you? Let's say he says 6. Then I'd say, okay, if the fastest way to get to you is 6, then according to you, the fastest way to get to me would be 7, right? And all I have to do is I have to ask every index before me this question, and I update myself every time I get a faster answer. So let's say everyone behind me allowed me to get to the end. First kar lijiye, all of the indexes behind me allow me to get to the end. I ask all of them कि अच्छा आप तक पहुंचने में कितने जंप्स लगे, आज आप तक पहुंचने में कितने जंप्स लगे, किसी ने कहा 3, किसी ने कहा 4, किसी ने कहा 2, किसी ने कहा 1, किसी ने कहा 7, कुछ भी कहा। हर किसी एक आंसर से मैं हर कोई यस कह रहा है ना, जिसने भी यस कहा होगा मैं उससे कहूंगा अच्छा तुम्हारी वैल्यू लेता हूं, which is the minimum number of jumps I need to get to you. Let's say someone says 7, and then I do +1 and I update this guy. But if my answer, if I already had another answer before you, let's say another guy had said 3 jumps to me and then 1 more jump to you, then I already have a 4 right now here. यहाँ पे कि the minimum number of jumps I need is a 4. Then if someone said 7 plus 1, I shouldn't take that answer, right? So the only recursive function relationship you need to see is ask everyone behind me. So min jump of mj, so let's say mj minimum jump of I is basically for all I less than, for all j, for all j in the range 0 till I minus 1. So all of the people behind me, I'm going to ask if the jth index plus the nums of j. So if u standing at u plus the value of u, कि आपकी जो value है, that can get me, if that jump can get me up till n minus 1, or basically I, if that can get me till I or greater than I, एक ही बात है, then that means that guy allows me to jump onto you in one step, right? In that case, I min jump of I, mj of I, mj of I will be equal to mj of j. Okay, what was the minimum jump to get to you, this index, the jth index, plus 1. But I'd also have to compare my previous old answer. So that means I have to be storing my answer somewhere. That storing of answer is going to be done in a DP array. What are the dimensions of the what are the dimensions of this DP array going to be? DP of x, let's say, stores the minimum jumps to get to x. What is the length of DP? Does anyone want to guess what's the length? Acha, guys, I might be going too fast. Does everyone get what's happening in the question? Yeah, I'm going too fast. Thoda sa lost ho rahe hain. If anyone's lost, please raise your hand because I feel like aaj feedback kam hai.
Can you repeat the question?
Like the entire question?
Yeah, the DP one.
Okay, so the
DP
question
one.
here is okay, you have an array. ठीक है, an array has values.
Yeah, I got that. I meant the recent one.
अभी
DP one.
I asked you कि अच्छा हमारे DP array के अंदर आंसर स्टोर हो रहे होंगे, previous answers, right? So DP of x represents the minimum jumps I need to get to the xth index. सही है?
Right.
How many answers do I need to store at max? What is the length of DPX? What is the length of DP, basically? How many indexes are in DP? What is the length of the array DP?
K minus 1, where K is the length.
K is the length of basically this array.
Yeah,
So why would you do K minus 1? You mean K, right?
because we don't need the number of jumps for the first one, right? That's where we start from.
Oh yeah, smart.
Okay,
Yeah,
we can.
you're right. Yeah, सही है. Like for simplicity, always keep that answer because those answers usually form your base case. But yeah, you're right. Technically, you don't need to store the answer. Like perfect. So the length of dpx is basically going to be n, or n minus 1 कह सकते हैं, लेकिन call it n because there are n possible locations. सही है? ठीक है, खैर. So what you would actually be using, you wouldn't actually be assigning mjx immediately. You would actually be saying mj of the minimum jump of j. इसका आंसर कहाँ स्टोर हो रहा होगा? It's going to be stored in dp of j, right? So you'd actually be wanting to update dp of I. dp of I, इसका आंसर निकल रहा है अभी. dp of I is equal to the minimum of the previous answer in dp of I, the answer I thought पहले से जो था अभी तक, plus कौन सा आंसर? the one I just got, which is basically dp of j. कि अच्छा मैंने j से छलांग मारी है, तो dp of j, which basically gives me the minimum jumps I needed to get to j, plus 1. तो इन दोनों का मिनिमम देखा जाएगा कि अच्छा मेरा प्रीवियस आंसर लेट्स से अगर 5 था और मेरा अब आ रहा है 6 plus 1, तो 7. मेरा पहले से आंसर आ रहा था 5. सो another previous index had told me कि अच्छा you can actually get to ith index in 4 plus 1 jumps, let's say. तो तभी मेरा आंसर 5 आया था ना. अब जो मेरे पास नया आंसर आ रहा है वो तो कह रहा है 6 plus 1. So 7 jumps is actually worse than my already previous answer. So then in that case, I wouldn't actually be updating, I'd just be putting the minimum, which would be the old value, right? So dp of I would actually be the minimum, which would be the old value of dp of I. So does everyone understand this recursive relationship? ठीक है? Does anyone want me to go over this one more time? I'm gonna assume everyone got the solution. Now, can anyone tell me how would I initialize DP of the DP का array? देखो यहाँ पे तो I'm always accessing my old answers, right? So my old answer always has to be there. Or how am I handling unknown answers? शुरू में जब हम बनाएंगे array, उसके अंदर क्या भरा होगा? Null भरा होगा, zero भरा होगा, infinity भरा होगा, negative infinity भरा होगा, क्या भरा होगा? Does anyone want to guess? कोई भी तुक्का भी मार दो, कुछ भी बोल दो.
Normal jumps होंगे, not minimum jumps. I don't know.
You're close, लेकिन normal jumps think a little more like intuitively. अच्छा, अगर मुझे normal jumps करनी होती, so if I don't know the answer to me, what is the best case that I know of so far? Let's say I'm looking at the 7th index and I've never found an answer for the 7th index. I don't know the minimum answer yet. That basically means the minimum answer in my mind is basically as high as possible, right? It wouldn't be zero as har dafa min zero. Bilkul sahi, Zoha. That's a good observation. It's not going to be some. So exactly, Sahil, it's not going to be zero. Zoha is right. She said it wouldn't be zero because har dafa min banna zero ho jayega, right? Negative values to hai nahi. So Zoha, think zero is the last answer that you would need, right? You want to be thinking in the opposite direction. What is the opposite direction of zero? Max is I. Could you explain what that means? Yeah, Aga, that's correct. Positive infinity. So Zoha was on the right track. She said it's not going to be zero. In fact, it's going to be the complete opposite of zero. It's going to be positive infinity because if you haven't found an answer yet, then your best answer so far is the worst possible answer. Any answer you get at this point would be better than your current answer, which is absolutely nothing, right? So you could put like a value like none there, but if you're playing it smart, you would just put infinity there, or int.max, yeah, math.infinity. If you're working with Python, you get the idea. So the highest possible value. What that would entail is any time that value would be updated to the like the पहली दफा जब वहां पर actually sensible answer आता कि अच्छा minimum jumps ये डाल रहा हूं मैं और मेरा previously कोई answer नहीं था, then it would automatically update to the new answer. Why? Because the old answer was actually infinity. So our DP array initially would actually look like this: infinity, 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 all the way up till the end, right? Except which value? This guy, because this guy would be a zero. I need zero jumps to get to you, right? And then everything aage would be filled. One more observation we can make is that the current recursive function that I gave you was a top-down approach, and it worked like it was finding पिछले values को देखकर कर रहा था. Could we say that the max of the ith index? Could we say the max of ith index is I as example? Second index I can take max 2 jumps, not more than that. Could we say the max of ith index is I? As example. Zoha, I don't exactly got your question. I can take max 2 jumps, not more than that. आप कह रही हैं कि अच्छा अगर वहां पर 2 लिखा हुआ है तो वहां पर मैं DP के अंदर 2 डाल दूं? Is that what you're saying? I'm gonna, like, instead of positive infinity, we can take I as DP of I. Zoha, think about what that would imply. That's basically you saying कि अच्छा अगर मैं DPI का मतलब क्या है? DPI का मतलब है कि what is the minimum number of jumps I need to get to the ith index? That's what DP of I के अंदर जो value stored है, that's what that represents. Let's say first कर लीजिए आपने उसको शुरू में initialize किया था by the values themselves. So you're claiming that dp of I is equal to nums of I initially, which is basically you implying that the minimum number of jumps I need to make to get to the ith index is the value at the ith index. If you think about it, the value at the ith index has nothing to do with the number of jumps I need, because that value is actually never seen in making the jumps till I. अगर मैं I तक पहुंच रहा था तो मुझे I की वैल्यू से तो कुछ मतलब ही नहीं है, वहां पे इन्फिनिटी हो, वहां पे -1 हो, 0, कुछ उससे कोई मतलब ही नहीं है. मुझे सिर्फ उन वैल्यू से मतलब है जो मेरे से पीछे हैं. So it certainly can be something like nums of I, because that has absolutely nothing to do with the answer of dp of I, right? It could be some information from the previous values, But as Aga said, it's actually going to be positive infinity. I hope that's clear. I was saying, okay, so I was saying one more thing that you could actually do this question is, I approached it by saying आखिरी इंडेक्स से सब पीछे वाले इंडेक्सेस से पूछो क्या आपसे मैं यहाँ तक पहुँच सकता हूँ, ठीक है. So if I'm actually finding any minimum jump of I would look at all the indexes behind me. I would ask them क्या आप पर खड़े हुए मैं I तक पहुँच सकता हूँ, क्या मैं अपनी जगह तक पहुँच सकता हूँ. अगर आपने जवाब दिया हाँ, तो मैं आपसे पूछूंगा अच्छा आपकी मिनिमम जंप्स का आंसर क्या है, और मैं उसमें +1 कर दूंगा और मैं अपडेट कर लूंगा अपने आप को. अगर बेहतर आंसर आया तो मेरा मिनिमम और कम हो जाएगा, राइट. इस तरह आखिरी का आंसर बेहतर हो जाएगा. लेकिन वी कैन एक्चुअली डू द सेम अप्रोच दैट वी डिड इन द शुरू की तरफ, है ना. वी सेड कि अच्छा आगे की तरफ बढ़ते हैं, ट्रू भरते रहते हैं. लेट्स डू द एग्जैक्ट सेम थिंग ओवर हियर. द मिनिमम जंप्स, लुक एट द डीपी अरे कितना होगा, इट्स गोना बी 0 इंफिनिटी 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 इंफिनिटी, ऐसा होगा ना, right? So let's start filling them from left to right. You'd stand at the first guy and you'd update all of the minimum jumps in front of me. ठीक है ना. Currently the minimum jump की value at this guy is all infinities and the first guy is 0, right? So I'd stand at this guy, I'd go to all of the locations in front of me and I'd update those values to +1 of my value. Why? Because this guy can get to this location and this location. जिसका मतलब है अगर मैं 2 पर खड़ा हुआ हूं तो फिर इसके मिनिमम जंप्स is gonna be my best value +1. That's gonna be the updation of these values. तो मैं इस वैल्यू को I can immediately make this value 0 + 1 कि अच्छा मुझ तक पहुंचने के लिए 0 जंप चाहिए थी, आप तक पहुंचने के लिए और आप तक पहुंचने के लिए मुझे +1 ऑफ दैट चाहिए होगा. सो मैं यहां पर क्या डाल दूंगा, 1 और 1. That makes sense? Does anyone have any confusion as to what I just did? Did everyone understand what the updation here was? ठीक है. अच्छा, then we'd go to the second value, which is 3, and we'd tell him, अच्छा, तुम जो है कहाँ तक जा सकते हो, +1, +2 और +3. So let's update all of these values. So this guy would go to this guy, and this guy, and this guy, and he would say, अच्छा, मुझ तक पहुंचने के लिए आपको 1 जंप चाहिए, तो इन तमाम जगहों पे पहुंचने के लिए it's gonna be 1 + 1 more jump. ठीक है. So he's gonna make this guy 2, this guy 2, this guy 2. अच्छा, इन दोनों जगह पे तो इंफिनिटी था, तो इसका आंसर 2 बन जाएगा और इसका आंसर भी 2 बन जाएगा, because that's a better answer than the previously known answer. But this guy already has an answer. His answer is currently 1. So I would try to put a 2 in here, but he would say, actually, you know what, I already have a better answer. तो मैं आपका आंसर क्यों लूं? So this guy would actually not change. And this is exactly what we were doing over here, right? We were saying, अच्छा, this is the ulta approach. This guy was saying, अच्छा, मेरे पिछले वाले लोगों से देखो, उनका अगर उनने कहा हाँ मैं आपसे अपने पर छलांग मार सकता हूँ, तो फिर मेरा आंसर है आपका आंसर +1. लेकिन अगर आपका आंसर बेहतर है, तो वही चीज हुई है यहाँ पर. 3 ने इसका आंसर अपडेट करने की कोशिश की. He said, you know what? Why don't you jump from me? Jumping onto me takes 1 jump, so jumping onto you would take 1 + 1, 2. But he already has a 1 wala answer. He already has an answer that says I can get to me in 1 jump, which is from here. So this guy would not be updated. But these guys would be updated, right? These guys would say, acha, mera previous answer to infinity tha, so this guy is actually giving me a very good answer. He's making me 1 + 1 + 1. So this guy would actually answer at 2. So now this is how your DP array fills. If you think about it, your DP array updates all the values in front of you, jahan pe basically nums of I ki range hai. Okay? So this guy updates 2 values in front of me, this guy updates 3 values. And you'd actually have to do this all the way until the end. You can't actually stop the moment you find an answer for the last guy, right? Because this guy claims कि अच्छा मैं मुझ पे खड़े हुए आपका आंसर एक आ रहा है, लेकिन आगे आओ, he could actually get you a better answer. ठीक है ना? He could actually get you a better answer. इस पे खड़ा होता, he would update this guy to +2, he was already +2. इस पे खड़ा होता, he would actually update this guy to 3. तो इसका आंसर पहले से 2 है, तो इसका अपडेट आंसर नहीं होता. Does everyone understand this approach? We can move on to the next question. ठीक है. In case you guys want to do this yourself, it's called Jump Game 1 and Jump Game 2 on LeetCode. Jump Game 1 is the true and false wala. Jump Game 2 is the minimum jumps wala. Let's move on to the next question. ठीक है. This question is called partitions. ठीक है. Let's say you have an array like this, 100. You just have an array of values. For simplicity, I'm going to be making an array in which the values are increasing. They don't have to be increasing. It can be perfectly random values. We're going to be working with integer values, obviously, to make it stuff easier. The idea is going to work for any, algorithm, like any sort of numbers. But for simplicity, I'm going to make the array increasing values. It makes it easier to explain it. So 100, 200, 300, 400. Actually, you know, 100 करने की क्या ज़रूरत है? Let's just fill it with one. Wait, bhai. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say these are their values. Okay? Now, I'm going to give you a number of k, where k represents the number of partitions you have to make. Let's say k is 3. ठीक है, you have to divide this array into 3 locations. तो 3 location का मतलब है आपको 2 divisions डालने हैं या 2 डंडे कहीं भी आपको डालने हैं जिससे आपके divisions हो जाएंगे. आपने हो सकता है यहाँ पे डाल दिया, यहाँ हो सकता है यहाँ पे डाल दिया. In each partition, you're going to sum up the values inside the partition. So इसका आंसर क्या आएगा? Let's say I put the divisions over here and over here. ठीक है? तो इसका सम कितना आया? 3 आया. इसका सम कितना आया? 7 plus 12 आया. इसका सम 13 plus 8 21 30 आया मेरे ख्याल से, right? 14 plus 16, yep, 30. So okay, look at these divisions. This division is a very bad division because सबको unequal divide किया गया है. ठीक है? What we would like to make is an optimal division between the partitions. ठीक है ना? Now necessarily it's not necessarily सबका equal हो पाएगा. It's very unlikely कि सबका equal हो पाएगा. ठीक है ना? तो लेकिन हम क्या चाहते हैं कि मैक्सिमम ज़्यादा से ज़्यादा फेयरनेस हो बिटवीन द डिविजन्स. सबका सम बहुत मिलता जुलता, बहुत मतलब लेवल्ड होना चाहिए. अगर इसका हिस्टोग्राम बनाया जाता, सो इसका 3 होता, इसका बहुत 12 होता, इसका बहुत ही बड़ा, लाइक 3, इसका 12 होता, इसका बहुत ही बड़ा. यू वांट द हिस्टोग्राम टू बी एज लेवल एज पॉसिबल. व्हाट वी बेसिकली वांट इज, इफ यू लुक्ड एट ऑल ऑफ द ग्रुप्स and you looked at the maximum value in any group, I would like to minimize that maximum value. Right? That makes sense. The maximum value across all of the groups should be minimized. Okay, I'm going to repeat that statement one more time. The maximum, make your partitions in such a way that the maximum sum across any partition. So you're going to go through all of your groups that you've just made. You're going to ask each group, what is your sum, what is your sum, what is your sum. You're going to look at the guy whose sum is the maximum. You want to minimize the maximum sum. And basically, that would be done अगर आप perfectly उनको level कर देते, बिल्कुल perfectly division कर देते. Let's say the sum of the entire array was 300. If you gave everyone 100, 100, 100, that would be a perfect division, right? That would be the lowest possible maximum sum across any array. Sorry, across any group. That would be the best answer. लेकिन realistically it's going to be something like 110 होगा, एक 110 हो जाएगा, एक 90 हो जाएगा, दूसरा 100 हो जाएगा. So then your answer would be, अच्छा, the worst case was 110. ठीक है ना? What you would like, given an array and given a value of k, what is the min cost of this? What is the best partitioning you could make? The best partitioning is basically the cost. A partition's value is basically equal to the maximum of the groups, matlab the sum of the groups. The partition's value is basically going to be the cost, or like basically a measure of how bad your partition is. That's going to be the value of the partition. Is going to be the maximum value that was of any group, the maximum sum of any group. Okay? I want you to find out the minimum partitioning. Sahi hai? Is the question clear to everyone? किसी को कोई ऐसा है जिसको सवाल नहीं समझ आया, so I'll explain it one more time before we move on to the actual question, because one is, you know, it's annoying when सब समझ रहे हो और दरमियान में someone else says. So everyone's clear on the, so can you clear on, sure. Alex, so we're saying that we have an array, right? And what we would like to do with the array is we would like to partition it in k partitions. ठीक है ना? Let's say k is 3. ठीक है ना? You would like to make 3 groups. You would like to make 3 groups such that the partitioning is as fair as possible. Now the value or the costing of a partitioning is basically when, let's say you made a partitioning, एक यहाँ पे डाला है आपने partition, एक यहाँ पे डाला. So this was the 3 groups. एक group ये, एक group ये, एक group ये है. You would find the sum of all of the groups and you would find the maximum value of any sum. That is the costing, or basically that is the value of your partitioning. You would like to minimize this sum as far as possible, right? So basically you would like to make this as fair as possible. The example I gave previously was, let's say if I looked at all of the values in my array and if I took entire sum that was 300 and I have to make 3 partitionings, The fairest partitionings that I could have hoped to achieve was 100, 100, 100. इससे ज़्यादा करूँगा तो किसी का तो आंसर थोड़ा सा ऊपर चला जाएगा, है ना? That is the ideal partitioning. You want to come as close to this as possible, right? But I just want to ask you, Ketcha, given an array, place partitions optimally such that we want the sums to be equal or close to equal. So aga, we just want the maximum of all the sums to be as low as possible. Just think of it like that. We want the maximum of all the sums to be as small as possible. That would get you the answer closest to the fair wala. That would get you the answer closest to the 100, 100, 100 wala. Okay, that makes sense. Does everyone follow what the question was? Does anyone want me to explain one more time? Is the array sorted? Zoha, no. I made that for simplicity. That's a good question. The array is not sorted. It can be unsorted. This is just, I made it for simplicity because it's obvious that this array, अगर मैं इसको array कर रहा होता तो आखिरी के partitions छोटे छोटे होंगे, फिर थोड़े बड़े होंगे तो पिछले वाले के सबसे बड़े होंगे. That would makes the most sense, right? Because these values are very small, so put more in this. Then these values थोड़ा सा बड़ा, तो इसमें थोड़े ज़्यादा करो. And the rightmost partition will be the smallest, right? Because these values are the highest concentrated. These are the highest valued ones. तो इसमें सबसे कम डालो, इसमें थोड़े से ज़्यादा डालो, इसमें सबसे ज़्यादा डालो. That's why I made it. So it was like intuitive. देखते ही आपको पता चल जाएगा कि partition क्या है. That's why I made it sorted. The arrays will not be sorted. सही है? अच्छा, now how would you find the ideal partitioning? सबसे पहले तो आप ये बताएं कितने partitions बन सकते हैं? What is the brute force approach of this? What is your sample space? What is the number of answers that you could actually explore? Think of how partitions are actually made. If I was making 3 partitions, how many dividers am I placing between the array? And obviously, okay, goes without saying, sorry, I didn't mention this. Each partition should have at least one element. Okay? Each partitioning should have at least one element. Khair. So does anyone want to guess how many partitions can I make in this array?
The number of elements to the power of the number of partitions.
So the number of elements to the number of elements.
Power,
You're close. Like, you're assuming that you can place 3 possible partitions over here. Then sorry, you're making like 3 possible यहाँ पे, 3 possible यहाँ पे, 3 possible यहाँ पे, 3 possible यहाँ पे, 3 possible. ऐसा नहीं है. It's actually not like that. If you think about it, the places, देखो कहाँ कहाँ तुम partition डाल सकते हो. यहाँ पर डाल सकते हो, यहाँ पर डाल सकते हो, यहाँ पर, यहाँ पर, यहाँ पर. In the gaps. ठीक है ना? So if you think about it, how many gaps are there? Every element has a gap before it. 9 से पहले एक gap है, 8 से पहले, 7 से पहले, 6 से पहले, 5 से पहले, सबसे पहले. So that gives you n gaps. लेकिन यहाँ पर तो gap नहीं है ना. So that basically means n minus 1 gaps. So there's n minus 1 locations to actually place your dividers. And you'd like to place your dividers in any of these locations. So if you think about it, you basically have n minus 1 places to choose from. You have n minus 1 places to choose from, and इनमें से you have a bag of basically possible indexes. So 1, 2, 3, 4. So the 0th index में तो नहीं डाल सकते आप.
n minus 1 is only when we have one partition, right? If you have 2 partitions, then it's n minus 1 multiplied by n minus 2.
नहीं. मैं कह रहा हूँ कि I'm just saying कि generally where are the places that you actually place a divider?
Yeah.
Right. So irrelevant of how many dividers I have, how many locations are there for the dividers? If I have n elements, then I have n minus 1 locations. That's clear, right? That's arbitrarily true, right? मैं कह रहा हूँ डिवाइडर मैं कहाँ कहाँ डाल सकता हूँ, मैं हर एलिमेंट के पीछे डाल सकता हूँ. ठीक है ना?
Yes.
n एलिमेंट्स हैं तो n minus 1 जगह हैं डालने की, क्योंकि इसके पीछे मैं नहीं डाल सकता, 1 के पीछे नहीं डाल सकता, वरना बकिया जितने भी आगे एलिमेंट्स हैं n minus 1 एलिमेंट्स, उनके मैं पीछे पीछे डाल सकता हूँ. सो n minus 1 जगह हैं जहाँ पर मैं डाल सकता हूँ पार्टीशन. सही है? So n minus 1 locations. So n minus 1 are basically the possible positions. Position 1, position 2, position 3, 4, 5, 6, 7, 8, 9. Let's say. ठीक है ना? I'm gonna pick any 3 of these. कि मैंने या तो second, fourth और 7th पे डाल दिया, या मैंने 2, 5 और 9 पे डाल दिया, या 1, 2 और 3 पे डाल दिया. What am I doing here? I'm actually just picking objects from a bag, right? Which is basically a combination. So think about it, it's basically n minus 1 C3. Right? That makes sense? That makes sense? Okay, perfect. So that's actually my space, and if I'm not wrong, n minus one C3 is I think it's exponential, right? I'm not exactly sure, but it's regardless, it's a very big number. So the brute force way to do this would actually be to explore all n minus one C3 partitions, and once you've made the partition, all you can do is it's a simple for loop. कि अच्छा मैंने यहाँ पे divider by डाला है, यहाँ पे divider by डाला है. So keep summing up the values until you find a divider, then डाल दो sum में. Keep summing these values, divider sum में डाल दो, divider sum में डाल दो, and store all these answers. These are your three sums. इनका maximum निकालो, costing निकालो, store this answer somewhere. And keep doing this for all of the partitions and keep updating your answer until you find the minimum answer. Every time you get an answer better than your previous one, minimum डाल दो, minimum update कर दो. अच्छा minimum अब तक 110 आ गया, मेरा minimum 109 आ गया, मेरा minimum 108 or 7. इस तरह आपके answers बेहतर होते रहेंगे. But that's obviously a very poorly designed approach. It's a brute force approach. We're going to be using DP in this, right? Acha, now, firstly, don't you need to place two dividers to divide the array into three, assuming हाँ बिल्कुल सही हमने आपने बिल्कुल सही कहा. Sorry, in this case there would be two dividers. If I'm making k is equal to 3, then sorry हाँ there would be two dividers. In this case it would be nc. So in this case हमने बिल्कुल सही कह रहे हैं, it would be n minus 1 c 2. Sorry. ठीक है, so खैर. So how would the DP approach for this look like? Now keep in mind, whenever we're doing DP, what is the core idea? We want to divide our problem into subproblems. सही है? So currently what parts of the problem do we have? पहली बात तो ये है हमारे पास problem के अंदर कितने divisions करने हैं, और फिर दूसरी चीज है what are our inputs to our current problem? एक तो है array और दूसरा है partitions k is equal to 3. ठीक है? Or if you're actually making, let's say k represents the groups, so p represents the number of partitions, which simply going to be k minus 1. So I'm going to be currently speaking in terms of partitions. ठीक है ना? So array and the number of partitions we actually have to make, because essentially groups तो बनाने हैं, लेकिन हमें decision किस पे लेना है कि मैं यहाँ partition डाल रहा हूँ या नहीं, divider डाल रहा हूँ या नहीं. So if you look at our problem, we basically have two parameters, the array and the partitions. Our array is basically an array of size n. If you would like to make subproblems of this thing, we would take fewer problems, we would take fewer elements of n. That makes sense, right? You've seen how this works in knapsack, right? We're going to be doing something similar to knapsack. We can fairly see how that's obvious in this case. कि हमारा array है, we don't want to be immediately processing the entire array at each timestamp. थोड़ा थोड़ा करके हम उसका आंसर बिल्ड कर रहे होंगे, ठीक है? And currently the final answer demands you to make p partitions, which is in this case k minus 1. अच्छा एक second. Let's see. अच्छा, did anyone record this lecture by any chance? I am recording, लेकिन you guys know मेरा corrupt हो जाता है. Hopefully नहीं होगा, लेकिन कोई कर रहा है? खैर. So in our current problem, we have n elements and we have to place p dividers, which is basically k minus 1, and in this case it's 2. ठीक है? So 2 dividers. सही है? For simplicity, let's work with actually 4. And we actually have to play 3 dividers. सही है? First कर लीजिए, आपको 4 groups बनाने हैं तो 3 dividers रखने हैं. What would a smaller subproblem look like? अच्छा, let's say you were building towards the answer और हम बिल्कुल आंसर के करीब हो रहे थे, ठीक है ना? What is the last thing you would have done in अच्छा मैंने ये कर दिया, अब मेरा आंसर आ गया. What is the last choice or what is the last action you'd be taking? You're placing dividers, right? What is the last thing you do? You place the last divider, right? That makes sense. So the last subproblem would look something like, acha, I am placing the third divider. I know the answer of my optimally placed 3 minus 1 divider. So 2. So I know how to place 2 dividers optimally, right? But I would also then have to consider, okay, acha, how many elements am I taking? There are 2 parts to my subproblem. So we're going to define our helper function something like this. n and 3. ठीक है? So given that I have n elements and I am placing the third divider, or I have placed the third divider, this basically gets me the answer. Helper of 3 returns this. The minimum p value, partition value, part value, after placing 3 dividers on n elements. ठीक है? Now let's think of this sub problem. Now let's think of this immediate answer in terms of our previous answer. Let's say first कर लीजिए हमें इसका आंसर निकालना था helper of n minus 3. This is the final answer. This is the actual answer what the question is demanding. ठीक है कि अच्छा given I have n elements और मैं 3 dividers डाल चुका हूँ. ठीक है, what is the minimum partitioning actually made? Well, let's say I knew the minimum partitioning of n comma 2. ठीक है ना, कि मैंने वो दो डिवाइडर्स डाले and I included n minus, let's say n minus 1 elements in this. So I have placed 2 partitions already and I have used some range of elements in that. अगर मैंने 2 डिवाइडर्स डाले हुए हैं तो हो सकता है इतनी रेंज इस्तेमाल हुई, इतनी हो सकती है, 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 इतनी हो सकती है ना? Let's say I know the optimal value, the minimum partitioning cost, given that I placed 2 dividers in either this range or in this range or in this range. ठीक है, 2 dividers का मतलब क्या है कि अच्छा मेरा एक डिवाइडर फर्स्ट कर लीजिए यहाँ पे आया, दूसरा यहाँ पर आया, और मतलब I counted these people in the second partitioning. ठीक है, तो basically saying कि अच्छा up till this range was divided into 2 partitions optimally, or this range was divided into 2 partitions optimally. If I am placing the third divider, ठीक है ना, I would obviously placing him on all of the elements that are left. ठीक है ना, अब मैं तीसरा डालने लग रहा हूँ तो इसका मतलब है मैंने प्रीवियस वाले तो सारे डाल चुका हूँ, है ना? Right? If I am placing the third divider, I am basically assuming अच्छा third divider या यहाँ पर आएगा, यहाँ पर या यहाँ पर, यहाँ पर या यहाँ पर. ठीक है ना, अगर यहाँ पर आया, that basically means I put the optimal answer somewhere over here. My optimal answer was in here and this had 2 dividers in it, 2 dividers डाले हुए थे और मैंने एक और divider डाल दिया यहाँ पर. ठीक है, अब I don't know what my optimal answer was. ठीक है ना, I don't know how much of the last few elements I need to include in my last answer. But I know this much. My optimal answer for n comma 3 will look something like this. I will put some arbitrary range into the last divider. Basically, अगर मैं third divider यहाँ डाल रहा हूँ तो इसका मतलब इतने previous elements से मैंने 2 divisions perfectly बनाई थी कि मेरा optimal answer, I optimally divided this into 2 dividers and I used this range for the last divider. यानी तीसरा मैंने यहाँ पर डाला basically. सही है? So my optimal answer for n comma 3 would look something like this. I know that when I placed my third divider optimally, that basically means कि अच्छा the range I chose, जिसके आगे मेरे elements सारे third partition में थे, उनका अगर मैं sum लूँ और I took the answer before me, कि अच्छा previous values की जो भी मेरी partitioning हुई थी उसका minimum maximum sum क्या आया था, और मैं इन दोनों का maximum ले लूँ तो या तो इसका आंसर हायर था या इसका आंसर आया था. That would be the lowest possible divisioning I could have made. In simpler terms, I'm basically saying that the third partitioning was either made over the 9, the 8, the 7, or the 6, or after the 5. The last partitioning was placed either over here, or over here, or over here, or over here. ठीक है ना? I'd have to be looking over all the possible places I placed them, and I have to assume, and I'd assume कि अच्छा अगर मैं यहाँ पर डाल रहा हूँ तो मेरा आखिरी पार्टीशन के अंदर ये आंसर है, प्रीवियस पार्टीशन का कोई ऑप्टिमल आंसर आ चुका है. ठीक है ना, एंड देन माई टोटल कॉस्ट वुड बी व्हाट, इट वुड बी, इसका ऑप्टिमल आंसर लेट्स से आया था 7, कि अच्छा ईच पार्टीशनिंग इन द 2 डिवाइडर्स मेड 7, और फिर इसका आंसर लेट्स से कुछ आ रहा है और इसका आंसर कुछ बन गया. सही है, थोड़ा सा I can feel I'm getting like a little complicated in this question. लेकिन let's write down the recursive relationship for this and you'll see how this is actually not that hard. अच्छा, I'm gonna stop the meeting because इसमें 4 मिनट रह गए.